Hello, everybody. Good morning, good afternoon, good evening from wherever you're watching us today. Today it's the last in series about importing any tool components or toolkit. I will basically show you the three things. I think that the most important subject of all these webinar series that you've seen so far. And the first subject will be basically showing you how to how to set the joints of inserts, and also how to set correctly the joint itself. And what are the rules about that? As in the previous webinar, you've seen only one rule about where is the Z for the insert and where is the Y regarding to the insert for the joint. Sorry. And the second subject will be basically the function for the military machines spindle orientation. And the last subject will be basically the revolver indexed position support. We went over this very nice function in SolidCAM 2021. So there will be a tons of information. So please stay focused and let's get started. I will be using, let me just close this one. I will be using basically the same part as I was using it in the past, and probably remember the holder that we have used earlier in previous webinar. And at that webinar, I basically shown two very important rules about the insert and the joint itself. The joint has to be at the bottom of the insert, but the insert coordinate system should be on the top where the Z is going up, while for the joint, the Y goes up, okay? Now, also I grabbed a couple of questions in the chat area, like, do we really need to position it like that? It's quite hard to orientate the tool correctly. And what are the rules for this? Yes, and I promise you that I will basically show you all the rules, about any inserts that SolidCAM will be that SolidCAM basically supports. So what is basically a rule? So I will start with modification of this holder, but before modifying the coordinate systems here, I will show you how to basically not remember everything what I'm going to show you, but actually how to find it by yourself. Okay, what are basically the rules? So you can find this. I think there's many different ways how you can get that information, but I will just show you my favorite. You'll just basically open the standalone toolkit and just open it in tool assemblies. The reason for the tool assemblies is because you can actually insert any insert that SolidCAM actually support. Now, basically based on the type that you want to import, you will select this type of the insert with the Shank, and it will directly show you how the joint coordinate system and insert coordinate system should look like and what are their orientation. So let me just add like external turning, internal turning, grooving. Of course, not in this way. Let me just remove this. Let me just start from beginning. So I will just external turning, then I will put internal turning, and then grooving, internal grooving, threading, external threading, and that will be it for now. Now, what is so nice about it, you can use a tool viewer here, and it will show you basically, let me start from external turning. It will show you how the coordinate system actually should look like. This is for the joint itself, and you can click also on the profile. Now, what is so nice is that you can actually see the axis orientation. As you can see, it goes through the really middle of the insert, just following, this. So it's like symmetric of these two edges. So let's go with another. As you can see, for the internal, it's the same. X is there. For the internal grooving, external grooving, X is going in this direction. For internal, it's going in basically the axis of the insert itself, like you can see here. For the thread, you just follow, basically the same with external turning and internal turning. And then we also have the internal threading, so it's basically the same. So the x-axis is the most important. It's always kind of on the middle and goes towards that. If you follow this rule with any insert type that are available on any tool or manufacturing on the tool manufacturer websites, you can basically download them. And before you actually define any of the shanks or the inserts, guys, I'm recommending you to first define it here in the tool assemblies so you can understand where the X should be. You don't really need to remember it. I could put everything in the pictures like in the presentations, but I think nobody will remember that. I think this is the best way to find out, how the insert should look like. So with that said, now we can actually talk about this insert over here. And I'll just basically use the external, turning here, and X must follow this position over here. You can also change the insert shape, and you will find, that X is actually not changing. I mean, it is changing depending on the insert type, but the rule is basically the same, okay? Except when the shape is R, but I think you got my point. All right, now when you know that, those kind of things that I'm going to show you in the next couple of minutes, it's basically just replicating what I just told you. So let's start with the insert over here. And for this, it is required a little bit defining some kind of sketches, in order to better define the insert itself. So I'll be hiding the shank in this case. And I will create, let me go over here. And I'll define, no, I need a point as well. And I'll define two lines basically, which represent my X and Z axis, or X and Y axis, depends of what we are going to define. So I'll just select a line. The line has to go in this direction for the X. So you can imagine like, let me go like this. So the X must go, let me go with the red, X must go here, Z or Y, and we'll see must go in this direction, and this should be the Y itself. So let's do that. I can go to the plane. So it's pretty easy, just define anything like in this direction. Then I will just create another line. You can do it like to be normal automatically, and I'll just click on the point, and you can click over here and you can say concentric, and he automatically knows where it is. That's basically it. Now you can use this sketch for all coordinate systems here. So I'll be defining for the joint itself. So for the joint, I'll be clicking this to be my X. For my Y, I want this one, and for my Z, this one over here. And this is the X orientation of my joint. So just to remember, X is the most important, okay? I'll be saving this. Let's go to the insert itself. My X, again, this one. My Y is this one, and Z, it's going up, but I want my X to follow, the same orientation up as for the joint. So I will just switch my X in this case, and Y. So the result should be the X follows, also the joint coordinate system. All right, so let's export this. So first I'm going to export, let's say, the insert itself. So File, Save As. I will be putting this in the same folder as I was doing it before. The turning, insert, and let me just put it into STL. Here it is already, so I will basically override it. I'll click on the options. Again, clicking on insert coordinate system, I'll be doing it fine. Click save and just override it. Great. Then I will unhide this one, the shank, and then I will export just the shank itself. So let's go again. There'll be a lot of this exporting, I could basically just export, guys, everything and just show you the main stuff, but I think it's also kind of nice to see the complete workflow of how I'm actually doing it. And now let me go with the STL. Actually, in this case, I have it over here. That's fine. So I don't need to change the name. And this will be, I think it's the joint here. The joint is actually the coordinate system of the shank. If you remember it, I think I didn't make a mistake. I will see it here. Yeah, exactly. So it will be completely fine. All right, so that's basically it. Let's go to our project, and I will be just editing this tool component. I'll be again using the webinar, the one that we used in the past. And this time, let me see which one it is. This one. So I will be deleting this one. And let me just create it again. And yeah, so let's choose a 3D model. Let's go to the webinar, turning, shank. Let me rename it and just open it. Rename it over here, put it there. Okay, perfect. Of course, we need to define the connections. So as last time, we'll just go over here. And you could probably note that I'm using a new version of utilities. I'll at least try to give you a short overview of what we have here new. Coordinate system macros, the icon is changed a bit, and we have a new options of vector that I'll try to cover by the end of the webinar, okay? So I would click on the coordinate system matrix. Yeah, and by the way, it's still in development version, so you will get it on the website quite shortly. So my master will be the joint, and the slave coordinate system will be, where it is, insert. I actually want to be insert joint. Here it is. Yeah, but I actually wanted to. Okay. So I'll be just clicking on, I'll just taking a snapshot here. I'll just move it to another screen so you don't actually basically see it at the moment. It's not so important. I'll go to the connection here and I'll just write here the values. The shifts are not the same. So let me just double check. So master, insert, that's okay. So let's see. So minus 24, 671, minus 4 point. And of course, guys, also somebody is asking me, can we improve this also a bit? There will be a direct input from the connection itself. We are looking to find a decent solution for this. For now, just use the utility. I think that will be okay for now. And as well as 58 here. So that's okay. Let's see. So the tool view. That looks great. So let's analyze it again. So X should go, follow this direction over here. And we will just insert this one. So I'll just delete this, put another. It's a 3D model. I'll just picking up this one. Rename. It's there. Okay. What we have to do, it's just to see if how it looks like in Part Tool Table Library. I will be basically putting it into magazine, guys. Okay, so I will be defining like at least 2 or 3 similar type of tools, okay, with the similar shanks, and then we are going to put it into the 3-side holder. I think that this is the main idea. So let me just let's use the Volt, a webinar. We'll use the shank. I'll just double click here. And on the insert, I will also double click here. Now, what is so nice here, let me just go to the connection. And the only, guys, what you really have to do is, to rotate the insert itself as it's coming like a default like that. But as you can see now, there is no need to do anything. It is in perfect position here. Now, of course, if you want to change the offset here, the nose point, you can do that, of course. For now, if you want to do that in the cutting point, you can, of course, change it here. So you can pick it here, or depends where actually it is located in machine environment. So I'll be clicking on machine preview. Here is in the machine preview, and let me just put that into my station. And this is how it looks like. Now, I say that my second subject will be basically the spindle orientation, guys. So, of course, if I rotate now this around the x-axis, and not shift, but this, of course, it will also work. I mean, this is just different orientation. But if you want to, for example, use this tool for main spindle and sub spindle, so you'll have basically two different kind of work offsets, you definitely need to use something that is called like spindle orientation. Changing the spindle orientation from 0 to 180 degrees will allow you to have tool in two different spindle orientations with two different tool offsets to be used, also in the main as well, also in the sub spindle. For now, I will just show you that this turning point here, it's just selected here. And you probably remember that we have here measured orientation where we can define also different B-axis angle. But I want to show you, I'll just stop here for a moment and I'll just save and exit. I'll be showing you option of activating the spindle orientation. Now, of course, for all the customers, I'm not recommending you changing these on your post, okay? So as this has to be really activated by your support and your post team. So basically, if you go to your upper third here in the options, you will have an option here, spindle orientation. This gives a machine capability or SolidCAM capability to use the rotation of your spindle. So you can basically put on and off or value and off. I'll set it to value and off. And what it changed in the toolkit the way how we can actually set our tool offsets. So if I go over here and click on our cutting point, let me just allow also machine preview here. So I have now the orientation, which is like a default one, but what is so nice that now we have here a spindle orientation function, which basically we can say like this. So I can click on the measured orientation and I can say here 180 degrees. I want just to use it like, just to show you how this looks like. So you can see basically in the preview, lively the orientation of your tool. Here it is. I like it. It's over here. So let me just use the one that it should be a proper one, okay? And here it is. Now, how this is matching, just rotate it over here. You will see this is the same orientation, and this is the point which will be actually basically the tool offset in this offset, okay? Now, if you want to use another one, you can add a new cutting point, and now you can measure your tool over here. So I can pick a different origin. I can set this one in this orientation. So basically, with the same tool item, I can have two different orientations used in jobs. All right, this is regarding to the spindle orientation, but of course, guys, I will be showing you even more advanced stuff with spindle orientation. This is so nice with the three-side angular holder that I think like most of our customers is waiting for this like for 5 years at least. Not so really common, but it's something really nice to have capability of using it with different shanks and sensors as well. So with that said, let's go to another example. I will be now using different, and I have received so many requests. Can you please show us this and this and this? So I pick up something. Let's see here. Yeah, it was a groove with 3 mm. Let me just find it. I think it's this one, but no. This one is groove. Maybe not actually. Let's see. Yes, exactly. Now this particular tool is just like 12 mm, so it's nice for the cutoff. Also groove, not for the cutoff, for the grooving, and also especially for the Swiss type machine. So I'll be using this particular one at the Swiss type machine. But what is so nice about this one is the very special insert. It's a groove, of course. And everybody I wonder, how we can define this, especially here. It has some kind of weird angle here. So how we can define this particular groove tool, yeah? So let's start with this. Again, if I don't want to show you again, guys, the stuff in the assembly that I've shown in previous, but basically the idea is that we will define a coordinate system where my y-axis for the, not the text, but where my insert, where my sorry, not insert, but joint coordinate system will going up here, and x is going in this direction. For the insert will be the same here, but for the insert it will go with a z here. Okay, so this is the main rules that we actually have. But here we have another problem. The insert height, it's not the same on this point and not the same on this point over here. And as well, it has here a slight angle, and also the same insert, basically it's like kind of mirrored in the middle. So how we can support this one? The idea is to bring your insert coordinate system on the level of this edge over here. And basically the joint will be at the very bottom of the insert, okay? So how to do that, guys? So first I will be defining a plane. And my first reference will be basically, no, the vertex. I don't want the vertex, but I want this plane over here. I want to be parallel to this one. And my second reference will be just this point. With this, I have the point and it's fully defined. So I can just basically move it over here. That's it. And another one will be, I will just define the plane. And another one will be, I want to be parallel. And the second reference would be the lowest point over here, which is this one over here. All right, so now the harder part, where to put the coordinate system. Now, as I said, in this case, it's not important. I would basically put it here in the middle of the insert. So I'll be just basically hide this one. Let's make a sketch, go over here. Let me make this a little bit more transparent. I want to click on this, convert it. Conversion of that entity here will give me possibility to put it really in the middle. So I'll just create it like this and like this. So I have basically all the elements that I need for creating the coordinate systems for the insert and the shank itself. So let's click this. So this is a boring part, but anyway, I'll do it. So I'll put that in the point. So my X is going in this direction, guys. Z must go up. So my Y it's here, Z goes there. So I'll just switch the Y axis. So Z goes up. I'll be changing this to insert coordinate system. And for the plane 2, I'll basically define a sketch. I'll pick on that point that we just generated and I'll just convert that entity. So I have here the point. That's all what I need, as I can create a coordinate system where my place, I will place it over there. My X will follow the same. My Y will go normal to this plane, and my Z will be over here like this. So Y goes up. It is kind of in the air, but don't worry, guys, that's completely fine. All right, so that's basically it. Now we are going to export this. One thing you can note here that I didn't define any coordinate system for Shank. You can see the coordinate system here at the bottom, showing the global coordinate system here, the origin. You can see that actually he is already there. So I will not touch it. I will just use the default one that is there. It's coming from the tool manufacturer itself. So let's export it. I'll be doing metric webinar. I'll put it into a Shank. Of course, guys, I just forget to hide this one. Let's start with the Shank. So again, metric webinar, turning Shank over here. I'll just hide this one. And again, the same stuff here. So there is something that I would like also to mention. Here I have the insert, but I need for the Shank. So I will use the default one. I'll use here course. And definitely, guys, this is quite simple shanks here. But if you have any possibility to make it, to simplify it, when you're building a very large libraries, make it as less detail as possible. I'm not cleaning any details here, but definitely you should consider removing some of the unnecessary rounds here, the corners, so which are completely not necessary for collision checking. I would definitely spend extra time if I really want to optimize my tool components libraries. Let me unhide here and hide the shank, and I'll basically save it as. Go to the insert. I'll be calling this the same one, just of course it's not the same, but this one, I think it's 3 mm, no, 0.5 actually. 0.5, and it's not, it's the STL. I'll do fine here, and this time I'll click on insert, and that's it. Save. Yes. Okay, so unhide this one. And what I basically need is just where is this coordinate system in comparing to the coordinate system 2, which is actually the joint. So I'll just click on joint and matrix, and he will already say that he will show me these things. So I'll just pick up this. So if you save coordinate system, but for the second one, the first one will be considered the main origin. Okay, so again, guys, move this over here, close the previous one. Let's go here. Okay, so edit tool components. I like to do first everything in tool components. Really, you don't have to do it. You can just directly use it in your library, in your part tool table library. But if you will ever use this again, it's better to keep it in tool components for sure. Turning, let's add shank here, square one. It's 3D model. Let's go over here. So webinar, turning shank. This is the one, so I'll just open it. Great. And what I have also here is the profile. As it is for the grooving, I'll just use the groove icon here. It's just, it will change the icon here itself. So let's go here. Okay. Of course, I should not forget to change the origin here position. I'll just basically copy it from what I already typed here, found out from the T matrix. And this is quite simple. This one is 0 actually. This one it's -90, and this one is 0. Just to double check it. Yes, it looks great. So don't guys be confused that why it should be over here. For the grooving, it should go normal to the insert here, X parallel to the shank. Okay. Okay. That's okay. Insert. Let's see the insert. Insert is perfect. It's over here. I like it. Great. So let's go to the part tool table library. As I said, I will use this tool in Swiss type, but anyway, I just want to see if everything works fine. So just do the webinar, turning here, double click here, and just double click on this one. Again, go here, just put 0. I just want to show you guys that this works like really, really nice. Now, even though you need to see it that I have no ground here, there's 0 in, let me go ahead and show you here. There is no radius there, and it's still detected, okay? Now you need to be careful. In some inserts, maybe there will be no possibility to detect the nose point, okay? And in such a cases, please, you can also in CAD, you can also pick here this edge normal to the plane that we created, guys, and create very small rounding here, like minimal. You can do like 0.1 or even smaller, just to be detected, okay, by the SolidCAM itself. In this example, it's just perfectly detected, so that's great. Okay, so this is the example of the groove, and the next example that I'm going to show you here is the thread. Okay, so with the thread, let's go not here. Thread is quite interested a bit, and let me just go where it is. I have two of these, one with the coolant option and one without. So I'll go with the coolant options. I like it more. It looks more better, much better details. And this is, guys, what I tried to tell you. In this example of the holder, this shape, it's pretty. It will kind of use a lot of memory to store it into STL. Maybe you can, make it a little bit more simpler to not take the necessary data. Anyway, the subject is the same. I will be mostly focused on the insert itself. So again, remember that in this example, let me just unhide. In this example, basically the X goes in this direction, okay, and the rest basically, for the joint as well in this direction. So I'll be hiding these, creating the coordinate system. Now I have lost my orientation. Okay, so it must go in this direction. Okay, so let me hide it. So there are at least 10 different ways how you can find the center of the insert. I'll be using one that I found that it's quite okay. I'll be just defining, simple line, another line, and I'll just make them. I hope I didn't make any relation, but okay. So I'll basically say that they are collinear with this edge over here. And the reason why I'm doing this is just to find where is the center, okay? If I really want to make it perfect, I will just then extend these edges over here. Nice. And then I'll just remove these. As I said, you can find different ways how to do it. I'll just, find here the center. I can do also again for this side over here. Here we go. So here's the point. Great. We have the X direction here. We just need to find, the Y direction. I'll just say that this is normal to this one. So I'll just say perpendicular, and we have all the elements that actually we needed. So I'll just make all construction line, save it, pick this, make a coordinate system. I care about my X-axis. I'll go a little bit faster if you don't mind. My Y goes in this direction, and Z goes normal to insert. Of course, switch the Y, so X goes in this direction. So I'll just save it. This is my coordinate system for insert. And at the bottom one, I will be creating another. Yeah, I can create a sketch in this case first. So first a sketch, and the reason is I just need this point over here. Oops, I just need this point over here. I will convert it. I have it now, and just create a coordinate system. The X again here, Y here, up, Y here, and Z follow this one. Perfect. All right, that's it. So let me unhide this. I will be first exporting the Shank. So I'll just do save as. Again, let's repeat the same process, guys. We are of course looking. I see the question. Of course, there is. We will try to detect all the coordinate systems so we can pick it and do somehow like automatic exporting. Okay, guys, but no promises for now. We will check for the possibilities. Shank. Yeah, this is just Shank. We have these STL. Let's do like this. It's course, and I will pick as a default. I think it's nice. Save. And Now I need for the insert. I'll do define. I'll go insert here. Perfect. This one is my joint. And I need basically the information towards this joint. So I'll just go to the utilities, click on the coordinate system matrix. I have it here right now. Let me go with the results here. Perfect. I'll close the previous one. It's on my other screen. Let's go to my tool components. So let's insert square shank here. 3D model. My webinar turning shank. This one, so I'll just rename it. Again, the same. Perfect. My joints. 913, 141.521. And here we have also some crazy number. Just to check if this is correct. It really looks to me. Perfect. And then we have an insert. So I'll be putting my thread. 3D model. You can also pick the name from here, guys. Great. Insert is perfect. Coordinate system is at the bottom. Let's see it. Okay, so I will be using my Volt again. And after this, guys, we are coming to the fun part, really. So let's add this one and let's add this one. Perfect. I think this is just perfect. And of course, don't forget, click on the insert, go to the connection, just remove this -90. Here you go, in perfect spot, guys. Of course, as with any insert, here you can check this, go to the orientation, change the origin to be, along the X, so you can pick up this line over here. Or you can also like shift it along the Z axis, guys, so you can go and maybe, use this point over here. In this example, I'll just use this one, and I'll just save and exit. Okay, let me just jump into questions. Do we have questions? Please. Okay, there is also questions like, can we do also for the inventor? For the inventor, basically is the same process, okay, except that you don't have these coordinate system matrices. We are working on the solution to have everything in new tool table, so we will keep you updated, okay? Good question. So how to set the pitch in threading insert when we have the 3D model? Basically, there will be no pitch in that case. You are okay, guys. So whenever you are using the STL, as I mentioned in previous webinar, whenever you use the STL, we just use this as a geometry. All the properties of the insert, you must, they disappear basically. So we don't know what is really all about. We are just taking that as a geometry. And we are considering, the tool offset point. Now, how to know? We don't know. If you pick up this one, you need manually to put, particular feed. Okay. There is also a request to put like necessary parameters, even though it's a STL. But for now, you need to care about these details, manually. Okay. Okay. So. And now the interesting part. So for now, I prepared for you very nice holder. You probably are very familiar all with this one. But this time I will not go through the old process of defining the coordinate system stuff, guys. I already created is the 3-side A63 HSK. And I will be just defining, exporting this one and using in this project. So just file, save as, and let me just try to rename. Is there? Yeah. So let me try to save this. I'll be putting it turning. Nope, wrong folder. Metric. Let's go to the webinar turning and like this. I think I already have it here. So anyway, I'll just, of course, I check it before if it works. So I'll just use for the webinar here, just you guys to see it. It's my holder, goes here, and that's it. So I'll just save it. Perfect. Okay, so let's go back into project. Of course, what we need more, I forgot to mention here. For each of, we need the join for each one of these. So I'll be taking for each of these a screenshot. And I'll just say joint 1. I'll move it here. I need for joint 2. I'll take it. And I need for joint 3 like this. Perfect. Okay, so let me go to my assembly, tool components library again. And here I have it. So I will be just defining the simple holder, and just I will pick up this. I'll be taking it like this, putting it like this, renaming it and renaming it. And let's go with the joint 1. Okay, so a bit boring part, as I need to know all the joint 1. So let me just, I will just basically write it here like -1 and not 10. And -35 here, 180, 180. Of course, guys, don't forget that this is not driven at all. So I'll just take a look. Oh, I forgot this part to remove. Oh, great. I'll just save it. I will not leave. I will not remove it. Okay, guys. So let me go back here. So it's kind of here, but it's not there. Okay, so let me save it. Save as. And the good thing about this one, maybe it's good that actually it happened. I showed you this a couple of times, but I think it's always good to mention that whenever you do something like overwriting the values, not the values, but overwriting the STL, you should not be worried about that something will happen. You'll need to define it again. There's no need for that. You just go back again to your tool components library, and you will note now that there is no need to redefine it. The join is there. As you can see, the join is there, and we'll be defining a new joint. So I will add a new static joint. So you can see the properties are taken from the previous one. Let me just hide this one. Let me find the second one. Okay, here it is. So -7.366, -10.758, -35. And this one, it's a little bit, of course, different. It's 0, 0, and 60. Now, these angles are so super and important later. And I will call this like joint 2. Of course, it's also not driven, and I will add another static point. And this one is 5.634. And also -35 here. And over here, we have also 0, 0, but here -60. Great. That's it. So just this one, it's joint number 3. Perfect. Let's see how this works actually in our pod. So I will define from our library. We have it over here. And the inserts that I'm going to use, let's see. Maybe I can use this one. I can put this one for sure. What about this? Yeah, I can put this one too. So I can copy this tool. I'll just pasting it here. Then I will take, for example, the 45 degrees one. Let me just, did I define it or not? No, I didn't. Maybe I didn't save it. Oh, here it is. Okay, sorry. So I'll just copy this and I will be putting it here. And maybe for the final, I will just define any, just over here, like this. Maybe rotating it here. But in joint 3, this one will be joint 2, and this one is joint 1. So let's take a look, guys. So joint 1, I just need to, shift it along the Y, so like -25. It's over here, perfect. For joint 2, let's see the joint 2 here. This one, it's perfect. Just I will move it a little bit along the Z here, so in the minus, just to have something more realistic. And third one is over here. Let me rotate it around the Y here. So it's like -90. I will also maybe rotate it first. Let me just first rotate it. So I'll just define like 180 here, and then just rotate it for 90 degrees. And of course, shift it for 25 in minus. All right, so that is how it looks. Maybe not so long in Z. And maybe I can actually use different length here, like 125. And then put here 0. Here it is, guys, completely 3 different inserts, 3 different joints. And now there is one thing that is missing. Now for each of these joints, we need to declare on which spindle orientation they are measured. So this is the last step basically for the joint 1. We don't need to change anything, I believe. So I will just run the machine preview here. To see everything, you need to do like right click and mount it first, so you can see actually the orientation. So as you can see, the orientation, it's perfect. But what this allows you to also, for this cutting point, you can now rename it, and you can say main spindle. But you can add another cutting point, and you can say back spindle 1. Of course, you can put anything you want. You can do like 1, 2, or A, B. It's really up to you guys. I like this for the webinar use like this. So measure the orientation 180. So I can use now this one. So nice. For this insert, I have already here 2 cutting points, but I will not use this one. But if you remember, we need to use 60 degrees, or in this case, actually maybe -60 degrees. Let me actually go more. It's 120. So I need 120 in this. For this one, maybe I will need 60, right? For this one will be, or -60, let's see, -60. So I have here 2 cutting points, also main spindle, sub spindle. Okay, so you can choose which one you want. And the third one, I'll just leave it as it is. Just I would change the measured orientation to be, you can also see, guys, everything, it's so nice. You can go in very positive or like -60, and that will be -60 or -120. Let's see. Yeah, -120. Here we go. I would like just to change the insert type. So beautiful. Okay, so here that's it. Let's see how this works in particular job. I'll just take the face. I'll just change a tool. Which one? Let's see. I'll be using this in join 2. So one very nice things, guys. We have improved also the tool selection. So if you have only one particular tool, or let's say cutting point, you can basically click over here and click on accept, okay? Or you can click on particular holder and click accept. So it's not really necessary anymore to go to the cutting point and then to accept it. If you try to do like something like clicking on this, as it has many tools here and tool offsets, if you try to do like selection, SolidCAM will tell you, hey, there is a multiple touching point, so please select only one of them. So in this case, it's impossible to select it differently than really clicking on the cutting point itself. So I'll just click on this one. I hope I selected the correct one. Yeah, this is the correct one. Let's save and calculate. Let's simulate it. I'll just using, the host cat, and here it is, guys. It's so nice. You can use it in solid verification. You can really, all these holders will be taken into account. So if you hit any of these shanks, it will be reported, especially in solid verify. And yeah, now the only point will be to select all of these in all the rest of the jobs, okay? But in this webinar, I think you understand my point, so I will not go further with this. All right, and the next thing, it's special request to show you guys, a very special insert. Let me go with that one. It's over here, the 5-star insert. Not this one for sure. Let me close this one. I think it's this one. Nope. Maybe I didn't even copy it. I think I didn't even copy it. Yes. Okay. Just give me a second. I will be on another screen, just making sure that I copied the right one. Just give me a second. Okay. I think it's this one. Yes. Okay. Let's see. Yeah. Okay. Here it is. There is a couple of features that I already defined here. This is the insert, and I'll basically delete everything up to here. So I basically take it everything from the scratch. Let me also delete this one. Yes. Delete this one. And this one. All right. So actually, I will leave the sketch here. So here's the shank, here's the insert, okay? And here probably you may ask, okay, how we can define this one. This is not like a two-sided insert, okay? It's, it has more sides here. Geometries that are on the top, also on the bottom, will basically confuse the insert itself, or let's say the main cutting area of this insert. So basically the idea of automatic noise detection is to reduce the geometry for this insert, okay? The way how you can do that is basically to remove the not to remove, but to split the solids of this insert. So basically, I have here create already the sketch, but really you can choose whichever you prefer. It can be even straight line here, but I basically choose this edge over here. I create basically a surface here and basically split those two into a solid. So basically this can be one geometry, this will be shank, and this will be only the insert itself. Then I will again select the groove, pick the same geometry, and this is how you can actually define this kind of inserts. I think it's not really necessary to go through the same thing, but guys, you will basically define in any edge. I will pick, for example, this one, the X in this direction, Z in this direction. But for the bottom, please select the bottom possible. So here you will have the split line here. So you define the plane in this direction. Again, make projection of that point, and again, define the Y up and red over here. I hope I give you another idea how you can really nice technique how you can do basically any insert. Okay. This is nice one. I will not do it, but you can basically try it. You will have it into you will be able to download it, so you can try it also on your side. And now the stuff what I wanted to show you. Yes, exactly. Swiss type. Let's go to this project over here. Okay, so with this one, I just want to add one tool that I have defined before. That would be the same that we have used. Is it this one? Let me try. I think it's, let's see. Yeah, this one, 12. And that will be, this one will be this over here. I define it on the tool number 5th position on this Swiss type. Again, don't forget to move this to 0. Perfectly. Here we have it. Now there is, guys, for all Swiss type fans, I want to show you one very nice feature that we implemented in SP2. Over here, you will be able to, when you click on the cutting point, here you can see this new button here with the 3 dots here that will allow you to, make a position more quicker than usually. So what I will basically do, I will make the shiftings, and stuff. But really on the Swiss type, all the offset is actually coming from this default tool position of your station. So how to move that, to our tooltip? Basically just click on this and then rest it position to the tooltip. And this is where your tooltip will be, of course. You need to shift it a bit if you want really to get correct spot here. But I hope you got my my point, that you can really now, actually it's 12. You can really set up your insert over here how it should be. Of course, you can now set position according to the tooltip offset, and now you can have even more better management where it is. Is it positive in X? Is it negative in X? If it's longer or if it's shorter. So it's located over here, just remember. I hope it's a kind of nice one. And the last thing for the final webinar today is to show you guys how to use a new feature that we have in SolidCAM, which is revolver indexed positions. It's first, let me show you the holder. And before I go there, I will actually use I will use my previous project. Let me open. I didn't touch anything. So turning, tools used, and it is here. So this is a fast twin holder for the turning tools. It has basically kind of indexed position over here. So basically it's the capability that the revolver on particular station will rotate for a particular angle just a bit, not completely to a second station, and allow this particular turning tool actually to be activated with different offset, okay? And of course, different revolver index position. So let's see how to define this in SolidCAM and what are the necessary options to activate in VMID. So I already defined here the coordinate systems. I didn't define all joints also for the second side. So my first is just X is going down, pretty much standard XZ orientation here, XZ orientation there. The only thing what I did here, my reference point was like I create a plane based on this edge over here, and then I defined the tool and the tool point there, okay? With that, I will just export my holder. I will go metric, let's go to the webinar. And here I actually already exported, if I'm not wrong. Yeah, I already exported it, so I will not do it again, okay? Then let's go to my let's go, and I remember I opened this. All right, let's go to the tool library, tool components. Webinar. And I will be adding my turning holder. Okay, here we are. I'll just rename it as usual, rename it, and that's it. Now, of course, we need to put the connections. Now I'll just basically take all my positions. I need basically position from holder to my joint one. And yeah, when we're talking about the vector, I will show that at the end. I'll take this screenshot here. Let me turn off all the rest. Okay. And then the joint two. Great. Let's take a look over here. So I'll call it joint one. My X orientation will be 0, minus 25, 324, and 57.924. And orientations here are just basically 0, 0, 0. My drive unit type is just not driven. I'll add a new static joint, my joint 2. My X position is minus 5, 33.5, and 63. And here we have 0, 0, and just guys remember this minus 15. So I'll just, where it is. It's here. So here's the holder. Here is the orientations guys here. Another, it's indexed for 15 degrees. It's not driven, so I'll just save. And let's edit part tool library. I will pick my lower turret for it. Of course, it's not for attachments on the upper turret. And I'll pick one of the points here. My station would be as it is going on the right side, so I'll pick this 11 so I have enough space here. But guys, of course, this is very important to mention. This is a property of a revolver. Not all machines with 12 stations have indexed positions, okay? Usually when machine is supplied with these indexed positions, you can see over here, you know, different index angles. So it will be 24, maybe it will be here 23, and so on and so on. Okay, so please pay attention on that. That what I'm showing you right now, it's on the NTX 2000. This particular machine doesn't have that capability, but anyway, you can use it. You know, I can use this example to show you how to activate this feature. So I will open this folder. Just I'll double click on it, and I will not put it on in my magazine. Actually, I'll put it on my station 11. Yes. So here it is. Orientation, it's completely wrong. So let me just put this on 0. It's different orientation, so I'll just put it 180. It's also another way just to show you that you don't really need to perfectly export the coordinate system. You can still use this mounting, you know, on station stuff. I'll be using already defined tools. So let me try with, actually I will use both of these. Where is one? This is 25. So I can just copy both, like let's say like this, paste. This is wrong one. You have an undo, guys. So let me just put it here. You didn't want to copy it, okay. Copy, paste, and I'll just repeat it again. So let me go to the joint. So I have, this is my joint 1, joint 2, okay. I actually took the property of previous one, so I need to basically orientate my stuff, you know, correctly. So actually, why not? Let me just try with general one. So like this, I will be just rotating 180 here. That's just perfect. And I'll just add the same one over here. Whoops. Over here. And this one will be for the joint 2. As you can see, he's already in that position, so I'll just rotate it 180 degrees. Here we go. Of course, I can make it more shorter. Let me just do that quite quickly. My length would be, let's say 110. And then I can go along the X just a little bit. And then over here, my length, 125, for instance. And this will be okay. Okay, so what we are missing here, it's same as with this tool. As you can see, selecting, let me close the tool viewer to not confuse us a bit. So if I'm switching to both of these tools, you can see that the revolver actually it's not changing the angle. Using this holder in this particular revolver will not be possible to make any turning with this tool, or at least now you actually will kill the machine with the shank with this edge over here. So you need an option to have indexed position and to measure it, your tool in indexed position. So how to do that, guys? So I'll just go 7 exit, and I will go to my lower turret. I will just click on option. Of course, for all the customers, it is not allowed just to change this parameter, basically, because it will have an influence to your tool offset and how it is coming from your post. So please contact your local support if your machine has this capability in order to change it, as it is a completely new option in 2021. And here in the lower turret, there is an option of a rotary turret interpolation. And if I say this to yes, I'll just 7 exit. Now I can go to my toolkit, find particular tool on 11, select my proper tool. Which one it is. You can do focused here, use the focused button. Then you can see which one it's selected, so you can basically switch it over. So this is that I'm interested to. You can go to your cutting point, and now here you have measure orientation, similar to the turret with the B-axis, but this time it's for the revolver. So you can click on this one, and 15 degrees it's automatically detected. And what you can see, guys, here in the machine preview is indexed position, and turret switch this to indexed position. So now you can see the revolver actually it's changing all the time. Let's see how this works actually. So let me just save it. Let me change this. So I will be using, for instance, my next job, my balance rough. I will be using my it will be this one. Just perfect orientation. And for my slave tool must be same radius, of course. Let me select this one. Let me find tool number 11. I think it was the second one, right? 0.4. Let me try the radius. I really want to show you this. So I'll try with this. Maybe it will not be perfect, but let's give a try. I haven't tried. Okay, works nice. So let me go to simulation. Here you go, guys. So indexed position here, upper turret here. Here we go. I hope really that you enjoyed this last webinar. Really, I also want to mention that to visit our forum if you have any more ideas, if you have any issues, if you have any feature requests that you would like us to implement it, please feel free to write us there, to send us a feedback about the new toolkit. And I will just quickly go through the questions if I have them. Let me just check them quickly. 1, 2, 3, but what happened here? Oh yeah, okay, nice question. To not forget the icon vector. Okay, I'm going to show you these guys mounting plan. And okay, also great webinar, thank you. And to not forget the Inventor Cam customers. Okay, guys, of course we'll check about the Inventor Cam for sure. I'm using the SP2. Okay. Yes. So let me just show you. So let me go back to this holder and show you the vector stuff. The vector, it's if you click on the vector, you have basically the reference coordinate system, which I will say here for the holder. And the next geometry, it can be geometry or position or however, you can click on this one and we will analyze the Z vector. And you will basically get, you can actually analyze the X vector, Y vector, Z vector, and you will get actually the shift and this three vector orientation. Now, when we do need this, if you remember my, I believe, second webinar where I talked about holders, angular one, here I used, pretty, here I use pretty parallel, joints to define the rotation point. But if you have some really strange position and an angle, which that could be difficult, getting this matrix with the sketches will not be so nice. Okay, so this is a feature that will allow you to pick, you know, on any coordinate system, but you don't need to really pick on the geometry. You can on the coordinate system, but you can pick also on the geometry. What is so nice that it also shows you here the how is it called? It shows you also this X, Y, and Z shifts. It's so nice, and the vector that we are actually analyzing. So you actually get here the vector itself. It's so nice, so powerful. It will be soon. It's still not, guys, in the download section on the website, but it will be there shortly. Okay, so we are making a QA checking on it. I think that's it. Yeah, about the shifting position, you can shift it to any position basically and get that data there. Quite awesome. Huh? Okay, with this, I will finish the webinar. Thank you so much for following these webinars. The recordings will be available with all content that I basically used. I wish you a pleasant rest of the week. And yeah, see you in the next webinars. Thank you.